Welcome back. So this is a final note video of chapter 5. You've finally done it. You've made it to the end. So today we're going to be doing pretty much exactly the same thing as yesterday, but we're going to be doing it with higher degree polynomials, okay? So it's just one additional step. Otherwise, it's exactly the same thing as what you've already done for me. Really quick review though is possible rational roots. So remember, possible rational roots come from the idea that you can take the factors of your first number, the factors of your constant, and then start dividing them. And that will create a list of every possible rational solution. So 1 minus 1, and then 1 minus 2. Or divided by, not minus, sorry. 3 divided by 1, 3 divided by 2. 5 divided by 1, 5 divided by 2, 15 divided by 1, 15 divided by 2. Okay, and that list will encompass every possible rational solution to that given polynomial if it has any rational solutions. All right, so that's just a quick review. Let's get back to the big idea, the big picture. So yesterday we discussed how to use the graphing calculator and synthetic division to solve and find all possible solutions, or all solutions. So here, the first thing that I notice, this time I have a degree of 4. So that means I'm going to be getting 4 solutions out of this thing. So it means that there's going to be a little additional work into this process, all right? But the process actually remains the same. When I'm finding all of the solutions, I'm going to go into my graphing calculator and I'm going to type it in. X to the 4 minus 3x to the cubed minus 3x squared minus 3x minus 4 and graph. So I type it in and I look at my solutions. Now this time, something that you'll notice is I have 2 nice solutions. I have a nice solution at -1 and I have a nice solution at 4. So this time I am being given 2 values that are able to be pulled out synthetically. Okay, so that's the key to today is when you have higher order things, you may have more than one number that can pull out. All right. Now the cool thing is it doesn't really matter which one you pull out first. Okay, it really doesn't. So I'm going to pull out that -1 first. Okay. So 1x to the 4, negative 3x cubed, negative 3x squared, minus 3x, and negative 4. Since I know I have a solution, you should already know also that that means that I should get 0 at the end of my process. So I pull down the first number, multiply, add. Multiply, then add, multiply, then add, multiply, then add. All right, so what has this done for me? Well, I got the 0 that I knew that I should because that's the solution. And remember, when you're getting a remainder of 0, well, that's telling you this solution, so that factor actually is a factor with the polynomial that was left, which is an x cubed from there minus 4x squared plus x from there minus 4. Okay, so basically again, synthetic division ripped apart that polynomial. It factored out that solution for me. Okay, so now basically this has simplified the polynomial for me. Okay, But it doesn't end there, okay? So the neat thing is I have another solution, right? I have another solution of 4. Now, the trick to this is I want to continue simplifying this process, right? So I've already pulled out that x plus 1. So now my focus is I want to break this down, okay? So now I'm only synthetically dividing on that piece that I would like to break down, okay? That's my ultimate goal here, to keep simplifying. So let's see what we've got. Pull down the first number, multiply, then add. Multiply, then add. Multiply, then add. And once again, I know that I did the right work because I'm getting a 0 as a remainder, and I knew that I should be getting that. So now let's look at what we have. Well, now we still have that. I just pulled that out, and now this is representing the rest of the polynomial. Okay, so a constant of 1, x squared. So what's left is an x squared and a 1. All right, so again, basically, when we're getting these remainders of 0, we're using this to help us factor out all of those pieces to the puzzle. Okay? And what is that meaning? Well, it means I have a solution of x equals -1, which we knew, x equals 4, which we knew. Now we need to know what would make that equal to 0. Remember, every piece needs to equal 0. Now, you should already have an idea that here we were only seeing 2 solutions, 2 x-intercepts. So these other 2 then must be imaginary, okay? And when you do the math, that's exactly what you end up with. I subtract the 1 over, square root, because a plus or minus is how I'm getting those last 2 solutions. Square root of -1 is just I. And those are your 4 solutions. Okay, so again, really it's the same thing as what I've been having you do. Now there's just one additional step that you have to synthetically divide twice to get it down to a quadratic that you can ultimately finish solving. All right, so I have 2 more examples for us to make sure you're feeling confident in this before I set you free. So for this next one, when you flip the page, again, we need to first off put this in the calculator. I'm going to erase that. I'm going to go into here. So x to the 4th power plus 4x to the 3rd power minus 12x squared minus 28x plus 35. Now here you're probably saying, oh my gosh, I see 4 things. But remember, the only things that pique our interest right now are the nice numbers, okay? So while I may be seeing 4 solutions, only 2 of them actually interest me. This one at x equals 1, 2, 3, 4, x equals -5, and this one at x equals 1. This one and this one aren't crossing at nice values, so I really don't need to use them yet, okay? That's going to be the final step of what I'm finding. But the fact I can see them should be communicating to you that you're going to ultimately be getting real solutions at the end, okay? Because I'm visibly seeing them as x-intercepts. So Let's go back and start this process. So we've already talked about how -5 worked, okay? -5 was a solution. So we're going to use synthetic division to pull it out. Bring down my first number, multiply, add, multiply, add, then multiply. All right, then add, multiply, and add. So we knew we should be getting a remainder of 0. Okay, that's why we were doing this. So now let's see what that leaves us. So because we had a remainder of 0, it means it actually was able to factor that out. And what's left is coming from here. This being my constant, my x squared, and my x cubed. So I have x cubed minus x squared minus 7x plus 7. So remember, whenever you are synthetic dividing, you get that remainder 0, you know that you are kind of factoring out that solution. But we can do it again because we saw graphically, we have another solution at x equals 1. So let's synthetically divide that out. Now remember, we only care to continue the simplifying process. We don't want to start over, we just want to continue breaking this thing down. So when I'm synthetically dividing the 1 out, I'm only concerned with that big piece, okay, the piece that's left. So let's synthetically divide this out. So pull down the 1, multiply, add, multiply, add, multiply, add, done. And again, I'm glad that I'm getting 0. I know that I should be because otherwise it means I didn't actually have a solution. So let's see what I have now. Well, I still have that. I didn't do anything with that piece. I just pulled that out. Okay, I just was able to factor that. And the remaining piece comes from this. My constant, my x, and my x squared. So it means that I have that. Okay? So what is this telling me? Well, it's telling me 2 solutions I already knew about. Okay? So 2 solutions I already had. The key is now we need to know, well, what's making this final piece equal to 0, okay? That's the last piece of this puzzle. I can add over the 7. Oh, then I can square root it. Whenever you square root, you get a plus or minus. That's how I'm getting 4 solutions total. And I like that I'm getting something that is real, okay? Because again, we were visibly seeing 4 x-intercepts, which means that we know we should be getting 4 solutions to this. All right, last one, and then I will set you free. So for this last one, again, first step, you always want to plug it into your calculator, okay? Find any nice solutions that you can, and then use synthetic division to do the rest. So we have an x to the 4 plus 5x cubed minus 5x squared minus 36. All right, so here I'm seeing 2 solutions. Seeing one back here at 1, 2, 3, 4, 5 at -6, and I'm seeing another one at 2. So right off the bat, this is giving me two nice solutions. So ultimately what that should mean is I'm going to end up with two imaginary solutions as well to total up to my 4 that I know I should be getting. So let's run through this. So let's pull out that -6. So I have a 1x to the 4, 5x cubed, -5x squared, no x's, remember, you need that placeholder 0, and then a -36. Pull down the first number, now multiply. Add, then multiply, add, then multiply, add, then multiply, add, and there you go. Awesome, I got the remainder of 0 that I knew that I should be. And so now let's see what that's leaving me with. I had a remainder of 0, so I legitimately was able to factor that piece out. The remaining factor comes from all of this. That's my constant, my x, x squared, x cubed. So far, I have this, okay? But I had another solution, okay? That solution of 2. So I'm going to use that solution of 2 to continue breaking that down. All right, so I use my 2. I'm going to break down that piece with it. Pull down the first number, multiply, add, multiply, add, multiply, add, done. I got the remainder of 0 like I knew that I should be. So now let's see what this is doing for me. Still have that. I didn't do anything with that. Just factored that out. And now this is giving me the rest. That's my constant, my x squared. All right. So really, these two solutions I already knew about. That is no surprise. What I really care about, though, is that thing, making that last piece, figuring out what would make that 0 to finish this puzzle. Now, unfortunately, square rooting isn't going to work in this case because you notice I have all 3 terms. So if I have all 3 terms, what that means is I'm going to need the quadratic formula. Okay? So quadratic formula, I'm going to do up here so I have more space. -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. 1 minus 12 leaves me a -11. And ultimately, I never want to leave a negative inside the square root. So I'm going to just pull that out as an I. And that is what you end up with. Now, you should like that this turned out to be imaginary. And recall the reason we like that is because we could only see 2 solutions, 2 of the 4. So that means the other 2 have to be imaginary, have to be unseen graphically. All right, so that is all for today. So do please go and finish off that summary for me, write down a little bit about what we've learned and talked about, and then make sure you come back ready to do your practice work.